Hey everyone, and welcome to a deep dive into Derricks safety.
Brought to you by Safety One Source.
That's right.
Absolutely.
So whether you are a seasoned safety pro, a crane operator,
Or working towards that crane operator license.
this one is for you.
It is.
We see these towering derricks.
You see them everywhere, right?
Yeah, on construction sites, all sorts of industries.
Yeah, all over the place.
Have you ever stopped to think about
How they work.
how they manage to lift those massive loads
Yeah.
and stay upright?
It's amazing the amount of weight
I know, it's incredible.
that can actually move.
That's what we're diving into today.
That's right. We're going deep on this one.
All right, so let's get into it.
OSHA 1926.1436.
There it is.
That's our source for today. That's what we're diving into.
That's the essential guide
It is.
for anyone involved with derricks.
If you're working with Derricks, you got to know this stuff.
Okay, but before we get into the nitty-gritty,
Yeah.
can we take a step back
Sure.
and make sure everyone's on the same page?
Let's do it.
What exactly is a derrick
Yeah. And what makes them different?
from other cranes?
Yes,
Right.
from other types of cranes.
Well, according to OSHA, a derrick is powered equipment
Okay.
with a mast or equivalent member,
Okay.
guy lines or braces, a boom,
Mm-hmm.
and a hoisting mechanism.
Okay.
They're designed for lifting and moving heavy loads,
Yeah. Right.
often in situations where you can't use another type of crane.
Okay. So there are situations where maybe a derrick is the only
It's your only
option that you have to get something done.
because of the space or,
Yeah.
or something like that.
Interesting. Okay.
Yeah.
So it's not just any crane with a boom.
Right.
It's this very specific
It's a combination of things.
combination of elements.
Yeah, it's got to have all of those things
Got it.
to be a derrick.
And 1926.1436 dives deep into how to use them safely.
Yeah.
You mentioned it, supplements.
Yes.
The general crane and derrick regulations.
Yeah.
What does that mean exactly? So you've got the general rules for cranes and derricks,
Right.
but this section gets into the different types of derricks.
Okay.
So A-frame basket breasts, Chicago, boom.
Wow, there's a lot.
Gin pole guy, sheer leg, stiff leg,
Yeah.
all different types.
So it's really tailoring
How does it
those guidelines to each
tailored guidelines for each one?
type.
Exactly, because
Okay.
they're all a little bit different.
Okay, so it's building upon that foundation
Mhm.
of general crane and derrick knowledge
Right.
with specific instructions for each type.
Yes.
And I've heard whispers
Mhm.
about something called a load chart.
Oh, yes, the load chart.
Is that as important as they say?
The load chart is very important.
Yeah.
It's like the Bible for your derrick.
Uh-huh.
It tells you everything that it can and can't do.
So it's more than just a weight limit.
Oh, it's way more.
I'm assuming
It is.
OSHA mandates specific information
Yes.
that all load charts must contain,
They have to have this stuff.
like the derrick's maximum capacity
Right.
at different angles,
At all the different boom angles.
boom angles,
Yes.
component lengths,
Yes.
details about the ropes used.
All that stuff, yeah.
Wow.
You gotta know what you're working with.
Okay, why is all that extra information so important?
Well, imagine you're trying to lift a load
Okay.
and you don't know how much your derrick can handle
Oh, that's a scary thought.
at a specific angle.
Oh, yeah.
That could be very bad.
Yes, definitely bad.
You could overload it. It could tip over.
That's the last thing you want.
You don't want that to happen.
No, you do not.
The load chart is there to prevent that.
Okay, so it's really a matter of safety,
Yes.
knowing all of that
Knowing your
information.
Yeah.
Okay, that makes it crystal clear why those charts are non-negotiable.
They are very important.
But knowing the limits is only half the battle,
That's true.
right?
You got to have a good derrick, too.
Yeah, the derrick itself needs to be built
It does.
to withstand those forces.
It's got to be strong.
Exactly.
OSHA 1926.1436C gets into the construction requirements.
Okay, so this is how
This is how it's got to be built.
it's actually put together.
Exactly.
Interesting, okay.
And they say that the load-bearing members
Okay.
have to be welded to very specific standards.
Oh, we're talking about...
We're talking ANSI WS D14.394
Wow, very specific.
or AWS D1.1.1.1 M 2002.
Okay, so you can't just slap some metal together.
No, you can't.
There's a science to it.
It's got to be done right.
And I imagine those construction requirements differ
They do.
depending on the type of derrick.
Yeah, different derricks, different requirements.
Okay, can
yeah.
you give us an example?
So, for example, guy barracks.
Yeah.
They need at least 6
Okay,
equally spaced guy lines.
so those are the cables.
Yeah, the cables that hold it up.
Got it. Okay.
Unless a qualified person
Okay.
or the manufacturer says otherwise.
So there's room for flexibility,
A little bit.
but it needs to be
But it's got to be
considered and approved.
Yes, by someone who knows what they're doing.
So you can't just be like,
Right.
Oh, yeah, I think this will be fine.
It's got to be documented.
Yeah.
It's got to be legit.
Okay.
And that documentation's got to have all the details about the guys, like how many there are, the spacing, the size, the grade, how they're constructed.
That's pretty meticulous.
Even how much they sag.
Really?
All that stuff.
Okay, wow.
It's important.
It sounds like there's no room for cutting corners.
Not when it comes to Derricks.
When it comes to Derricks safety.
No way.
Not if you want to avoid disaster.
Nope.
Now let's talk about stiff leg Derricks.
Okay, stiff leg Derrick.
Instead of guy lines.
Right, they've got those big legs.
Those are the big beams that give that A-frame look.
That's them.
What are the specific rules around those?
Well, you got to have at least 2 stiff legs.
Okay, at least 2.
And they've got to be strong enough to handle the loads at any point during the operation.
Okay, so it's all about stability.
It is.
No matter how heavy the load is.
That's right.
Got it.
And the mast base also needs to be designed to allow for rotation and deflection.
So it needs to be able to move?
Yeah, it can't be too rigid.
Interesting.
It's got to be able to handle the stresses.
Okay, and then we have gin pull Derricks.
Oh, yeah, gin pull Derricks.
Those require careful consideration as well.
They do.
And they're guy lines.
Uh-huh.
They need to be sized and spaced to ensure stability in both the boomed
so whether it's leaning
and vertical positions
or standing straight up.
So whether it's leaning or standing straight,
got to be stable.
It needs to be rock solid.
Exactly.
But what if the guy's setup just can't?
Yeah. What if you can't do that?
Guarantee stability in both positions.
That's a good question.
What happens then?
Well, then the employer has a big responsibility.
Okay.
If the guidelines don't do the job, that Derrick can't be used in an unstable configuration.
Okay.
So you can't just say...
So safety trumps convenience.
The safety first.
Every time.
Every time.
That's a really good point.
You can't cut corners.
It's not just about following the guidelines.
It's about understanding.
It's about understanding the principles of stability and using good judgment.
You got it.
Speaking of unique configurations, Chicago boom Derricks sound interesting.
Yeah, those are the ones...
What makes them different?
They're designed to be attached to a host structure.
Okay.
Like a building.
Got it.
So you might see those on construction sites.
Okay.
Or maintenance work in tight spaces.
Okay.
Their fittings have to be designed to allow it to swing at different radii.
So it's like a Derrick and Derricky. And mounting heights.
Specifically made to work in those confined areas.
Exactly.
Where a regular crane...
Where a regular crane wouldn't fit.
Wouldn't fit.
Right. Interesting. Okay.
And they got to be able to handle the forces.
Right.
And prevent the boom from lifting out under tension.
Okay, so it's really important that those fittings and attachments are really secure.
Yes.
Okay.
Now let's talk about anchoring.
Anchoring?
That's a big one.
That's got to be pretty important for stability.
It's huge.
I can only imagine what would happen if a Derrick
it wouldn't be good.
Wasn't properly anchored.
It would be a disaster.
And OSHA knows that
OSHA knows.
1926.1436D
that's the one.
Is really strict about anchoring.
Very strict.
It mandates the use of anchoring data.
You got to have the data.
Developed either by the manufacturer or a qualified person.
Someone who knows what they're doing.
So you can't just eyeball it and hope for the best.
No way.
Absolutely not.
And the specifics depend on the type of Derrick.
Okay.
So guy Derricks.
Okay, let's start with guy Derricks.
Not only does the mast base need to be anchored, but the guys themselves need to be secured to the ground.
So both are anchored.
Both anchored.
Interesting.
And the whole system has to be able to withstand forces.
Both horizontal and vertical forces.
It sounds like a very carefully calculated...
It's all about balance.
Balancing act, making sure every force is accounted for.
And I have it all covered.
And counteracted.
Yep.
And for stiff leg Derricks...
Stiff leg Derricks.
It's similar.
It is.
But instead of guys, you're focusing on securing the mast base and the stiff legs themselves.
The legs themselves.
Got it.
And they got to be designed to withstand the maximum load.
So each type has specific anchoring requirements.
Yes.
But the goal is always the same.
The goal is always safety.
Making sure those anchors can handle...
make sure it's anchored.
whatever forces the Derrick might throw at them.
Absolutely.
Exactly.
Now let's talk about the lifting power.
Okay.
The swingers and hoists.
Okay. Now those are
important.
The parts that are really moving that load.
Yeah, they're doing the heavy lifting.
So OSHA has a lot to say about those.
OSHA does?
See, 1926.1436E focuses specifically on hoists.
Okay.
So the base-mounted drum hoists, they got to meet the requirements in ASME B30.7 2001.
Okay, so that's
a whole other set of standards.
wow. So it's like a chain of regulations,
one after another,
all building upon each other
to make sure it's safe,
to create a comprehensive safety net.
Exactly.
I like that.
That's a good analogy.
So when it comes to new hoists, OSHA requires them to be load tested.
Yes.
To at least 110%.
At least 100.
Up to 125%.
Yeah, up to 125 of their rated capacity.
Unless the manufacturer says otherwise.
So there's a little bit of wiggle room.
But not much.
But not much.
Okay, so this is ensuring that they can handle a little extra weight.
Yeah, you want to make sure they've got a margin of safety.
Just in case.
Just in case.
What about hoists that have been repaired or modified?
Good question.
Those need to be load tested as well, I'm assuming.
In those cases, a qualified person has to decide, okay,
if load testing is needed.
So it's not just fixing the issue.
No, it's not.
It's verifying that the fix didn't create new problems.
Exactly. You want to make sure it's still safe.
Exactly.
And if they decide it needs testing,
okay,
then it's the same procedure as a new hoist.
What exactly does that load test involve?
So you're going to lift the test load a certain distance, hold it there to make sure the brakes are working, lower it, stop, hold it again.
So it's really putting it...
Yeah, you're putting it through its paces.
Through its paces.
Making sure everything's working right.
And a competent person has to give the green light before it can be used again.
Absolutely.
Okay, so there's a lot of checks and balances involved in this.
Safety is paramount.
Absolutely.
You can't mess around with hoists.
Now, are there any other key elements besides the hoists and swingers that we need to consider?
Let's talk about operational aids.
Okay.
These are features that help operators use the Derricks safely.
Now, this is where it gets interesting.
It does.
What kind of operational aids?
So OSHA 1926.1416 covers operational aids in general.
Right.
And it applies to Derricks.
Okay.
But there are some exceptions.
Exceptions always make things interesting.
They do. So for instance, unlike other cranes, Derricks aren't required to have a boom angle indicator.
Wait, really?
Yeah.
No boom angle indicator.
Not required.
But knowing the boom angle seems crucial.
It is crucial.
For safe operation.
You got to know what angle that boom's at.
Yeah.
That's why if you don't have an indicator, you've got to have alternative measures.
Okay, so how do you...
So you could mark the boom hoist cable with caution and stop marks.
Okay, so it's like a visual guide.
Yeah, it is.
To help the operator.
So they know when they're reaching the...
Stay within the safe operating range.
Exactly. Another option is an electronic device that signals the operator.
Or automatically prevents the boom
from
going too far.
So it's like a safeguard.
It is.
Whether it's a simple marking or more advanced technology.
Exactly.
And there's an important change that went into effect in 2010.
There is.
Derricks manufactured after that date with a maximum capacity over 6,000 pounds.
Big Derricks.
Okay, so big Derricks have to have a load weight capacity device.
So that tells them how much weight they're lifting.
Okay, so it's built in.
It's built in.
What if a derrick isn't equipped with one of these devices?
Good question.
What happens then?
So there are some temporary measures.
Okay.
You can rely on manufacturer information, industry calculations.
So you still need to know how much you can lift.
You got to know that before you lift.
Before you lift.
Absolutely.
And if a load weight capacity device malfunctions,
it happens.
It needs to be repaired.
It does.
Within 30 days.
30 days.
Okay.
Unless there's a parts delay.
Okay, so there is some flexibility,
a little,
but it needs to be fixed.
It does.
As soon as possible.
As soon as possible, because that's a critical safety device.
Absolutely.
Now let's talk about testing.
Testing.
What happens when you get a brand new derrick?
Okay, yeah, you wouldn't want to just fire it up.
No.
I hope for the best.
No way.
There has to be a testing phase.
There is. OSHA 1926.1436G.
There it is.
Outlines the testing process.
Okay, so this is for new.
For new or reinstalled derricks.
Or reinstalled derricks.
Yeah, so first you got to check the anchorages. Including the structure the derrick is attached to.
Okay.
And a qualified person has to approve those.
I got it.
And if you've got rock or hairpin anchors, they got to decide if they need special testing.
So even the anchor points are crucial.
They are.
In the testing phase.
Yeah, they got to be solid.
What happens after the anchorages are approved?
Then it's time for the functional test.
Okay, so this is
where you run it without a load.
So it's like a dress rehearsal.
It is.
Before the main event.
Exactly.
Okay, what do they do during the functional test?
They're going to lift and lower the hook
Okay.
Raise and lower the boom.
Okay.
Swing it in both directions.
Okay.
Test any limit devices.
So it's like a full checkup.
It is.
Making sure everything is working.
Making sure everything's good to go.
And then comes the load test.
Then the real test with the actual weight.
So this is the real deal.
This is the big one.
Okay, what does that involve?
You got to use a weight that's at least 100%.
Okay.
But no more than 110%.
Of the Derricks rated capacity.
Of the rated capacity.
Got it.
Or the maximum anticipated load.
Okay.
Whichever is greater.
Got it.
So you got to pick the bigger number.
Okay, and then what happens?
They're going to hoist the load, swing the derrick.
Okay.
Boom, up and down, lower the load.
Wow. So they're
testing everything.
Putting it through its paces.
They are.
With that heavy load.
Wow. You got to make sure it can handle it.
And who makes the final decision?
The competent person.
On whether the derrick is fit for use.
The competent person who's running the tests.
Okay, so they have a lot of responsibility.
They do.
They also have to document everything.
Yes.
The date, the results, their name.
All that good stuff.
Okay.
And those records have to be kept.
Until the derrick
is retested.
Dismantled.
Yep.
So it's not just about doing the tests.
Oh, it's not.
It's about keeping a clear record.
You got to have a paper trail.
For accountability.
Absolutely.
Future reference.
Yes.
In case something happens.
Now, what about repairs, modifications, additions to the derrick?
Good question.
Do those trigger any load testing requirements?
If the repairs or modifications could affect the derrick's capacity.
So anything that could affect its safety?
Yeah.
Okay.
A qualified person has to decide
right.
if a load test is needed.
Okay, so again, it's not just
about fixing the problem. It's about making sure
it's still safe.
That the fix hasn't created any new problems.
You don't want to create more problems.
Exactly.
And if they decide a load test is needed, it's the same rigor as for new or reinstalled derricks.
Got it.
Okay.
Safety first.
Always safety first.
Now let's talk about something that might seem a bit out there.
Okay.
What happens if the power goes out?
Okay, this is not something you would normally think about.
Oh, no.
But it could happen.
It could.
What happens if the power goes out?
You got to have a plan.
While a derrick is in operation.
OSHA's got us covered.
They do?
They do.
Nope.
1926.1436J.
Okay.
That tells us what to do.
Okay.
So if the power goes out,
yeah,
the operator has to stop operations safely.
Okay.
Set all the brakes, turn off the controls, and make sure the derrick is safe before the power comes back on.
So it's like hitting the pause button in the entire operation. Everything stops.
Okay, and then once the power's back on, they can't just hit play and keep going.
Not quite.
Okay.
They got to make sure the derrick is safe to operate.
So it's like
maybe inspect the equipment.
Mini safety check.
Yeah. Reset any safety device.
After that unexpected interruption.
Exactly.
Got it.
You want to make sure everything's still good.
Okay, so we've covered power failures.
We have.
Now what about winch heads?
Winch heads.
They're used for controlling the ropes.
Yeah, they are.
But what are the safety considerations?
Winch heads can be dangerous.
Okay.
If they're not used right.
So how do you use them safely?
OSHA 1926.1436K.
There it is again.
Has a couple of rules.
Okay.
First, no one should handle the ropes on a winch head without the operator knowing.
Okay, so it's about communication.
It is.
Making sure no one's making unexpected moves.
You don't want any surprises.
That could catch someone off guard.
Exactly.
Got it.
And the second rule is that the operator has to be within reach of the controls.
Okay.
While the winch head is being used.
So that they can shut it down quickly if anything goes wrong.
Exactly.
Okay, so it's about having that quick access.
Just in case.
To the controls in case of emergency.
You never know what might happen.
So we've covered winch heads.
We have.
Now what about securing the boom? When the derrick isn't in use.
That's important too.
What are the procedures around that?
So that's covered in OSHA 1926.1436 meters.
Okay.
And it depends on how long the derrick is out of service.
Okay, so different time frames.
Different time frames, different procedures.
Got it.
When the boom is fixed in a position, they got to engage positive holding mechanisms.
So this is like
dogs or paws.
An extra layer of protection.
Yeah, it is.
Make sure the boom stays put.
You don't want that boom moving.
Exactly.
What about longer periods of downtime?
Like weeks or months?
Yeah, like 30 days or more. You need to take more extensive measures.
Okay, what do you do then?
So you could lay the boom down.
Okay.
Secure it to a stationary member. Lift it to a vertical position for guy derricks.
Yeah.
Or secure it against the stiff leg for stiff leg derricks.
So there are a few different options.
There are.
Depending on the type of derrick.
And the situation. So Each derrick type has its own preferred method.
But the main idea is to prevent that boom from moving.
You got it. You don't want any surprises.
Exactly. Now, we've talked a lot about different types of derricks.
We have.
But have you ever wondered about A-frame derricks?
Oh, yeah, A-frame derricks.
Those are pretty common.
They are. They're pretty easy to spot.
Yeah. What makes them unique?
Well, they've got that distinct A-shaped frame.
Right. It's like a pyramid with only two sides.
Exactly. Two legs that spread out from the top.
And that gives them their stability.
That's what gives them their stability.
That shape just seems like it would be inherently stable.
It's a simple design, but it works.
Okay, so they're used for lighter lifting tasks.
Yeah, compared to some of the other derricks we talked about.
But that doesn't mean safety is any less important.
No way. Safety is always important.
Of course. So what makes A-frame derricks unique when it comes to safety?
Well, first of all, those legs need to be securely anchored.
Right, because if those legs give way...
it's not going to be pretty.
Not pretty at all.
So anchoring is crucial.
Just like with the other types we discussed.
Exactly. You got to make sure those legs are solid.
And the angle of those legs matters, too.
It does. You need the right angle for stability.
So it's all about balance.
Balance is key.
What about the lifting mechanism?
Ah, yes, the lifting mechanism.
Are there any specific considerations for A-frame derricks?
Well, the lifting mechanism,
okay,
whether it's a winch or a hoist,
right,
needs to be sized and maintained properly.
Okay, so just like with the other derricks,
exactly,
regular inspections are crucial.
You got to keep an eye on those things.
Because a worn-out cable or a faulty brake?
That could be disastrous.
Definitely disastrous. So it's not just about the structure itself.
No, it's not.
It's about all the components.
Working together.
Working together safely.
That's right. And you can't forget about the load itself.
Right, the load.
You got to make sure that's secure.
Yeah.
Proper rigging is essential.
So no matter what kind of derrick you're using.
No matter what.
You have to make sure that load is secure.
You don't want it coming loose.
And I imagine A-frame derricks have a limited lifting capacity.
They do. They all have limits.
Just like other types.
That's where those load charts come in again.
Right, so you need to know.
You got to know how much it can handle.
What you can safely lift.
At different angles.
Different angles.
Different configurations.
Okay, so load charts are
essential.
A universal must-have for any derrick operation.
They are. They're like a safety manual.
Tailored to each specific lift.
Exactly.
And just like with any other type of derrick, A-frame derricks need to be inspected regularly.
But regular inspections are key.
We're talking about checking everything.
Everything, the structure, the mechanism, the anchor points.
Everything. Okay, so it's giving it a thorough checkup.
Make sure it's in tip-top shape.
To make sure it's ready to work safely.
Exactly. Now, you might be wondering if there are specific OSHA regulations for A-frames.
Does OSHA have a separate rule book just for A-frames?
Not a separate section, but all the general requirements still apply.
Okay, so even though they're smaller...
They might be smaller.
And simpler in design.
But they still got to meet the same standards.
Than some other derricks.
That's right.
They still need to meet those rigorous OSHA safety standards.
Safety first.
Safety first, always. Okay, so now let's shift gears and talk about training.
Training, that's a big one.
You're absolutely right. We can have all the regulations and safety features in the world.
We can.
But if the operators aren't trained properly...
it's all for nothing.
It's all for nothing.
You've got to have trained operators.
Absolutely. So even though OSHA 1926.1427, which covers operator qualification and certification, doesn't specifically mention derrick operators.
It doesn't.
The need for training is undeniable.
It is undeniable. These machines are powerful.
They are.
They can be dangerous.
And operators need to know how to handle them safely.
They need the knowledge and skills.
Absolutely.
Yeah.
So let's talk about derrick operator training.
Let's do it.
What are the key elements of a good training program?
Well, first of all, training should cover the specific types of derricks.
So it's not a one-size-fits-all?
No, it's not. The training needs to be tailored to the equipment they'll be operating.
So operators need to understand the nuances.
They do.
Of each derrick type.
Yes.
Its capacity, its limits, its safety features.
All that stuff.
And potential hazards.
They need to know those machines inside and out.
Makes sense. What else is crucial for effective training?
Well, deep dive into OSHA 1926.1436.
Right, of course.
That's a must-have.
That standard covers everything.
It does construction anchoring inspections, emergency procedures.
It's like their safety Bible.
It is.
Guiding them through every aspect. Of derrick operation.
And it's not just about memorizing the regulations.
Right.
It's about understanding why those regulations exist.
So it's about turning those regulations into practical knowledge.
Practical knowledge.
That they can use on the job site.
Exactly. That's the key.
Now, what about the practical side of things?
The hands-on stuff.
How do we make sure operators...
You got to get them behind the controls.
...can actually handle these machines safely?
That's right. Practice makes perfect.
So, hands-on experience...
Social.
...is absolutely crucial.
You can read the manual all day long.
Right.
But until you actually operate the derrick...
Yeah.
...you don't really know.
It's like learning to drive.
It is. You can study the rules.
Yeah.
But you got to get behind the wheel.
Exactly.
So hands-on training.
It's about bridging that gap.
Yes, it is.
Between the classroom and the job site.
Real-world experience.
Developing the skills and reflexes.
That they need to work safely.
They need to work safely and effectively.
Exactly. And it's important to remember that training isn't a one-time thing.
Right. It needs to be ongoing.
You need refresher courses.
Okay, so why are refresher courses so important?
Well, things change.
Right.
New technologies emerge.
Right.
New safety practices.
Mm-hmm.
You got to keep those operators up to date.
So it's about continuous improvement.
It is.
Making sure they're always learning.
Always learning.
And staying ahead of the safety curve.
That's right. You got to stay ahead of the game.
We've talked about the importance of training. In-depth knowledge of OSHA standards. And hands-on experience.
That's the trifecta.
But what about the people?
The trainers.
Delivering that training.
That's a good question.
What qualities should we be looking for?
Well, ideally, you want someone with experience.
In a derrick operator trainer.
Lots of experience, years in the field.
So it's not just book smarts.
Nope. It's about real-world experience.
They need to be able to share their stories.
They do.
The lessons they've learned.
The mistakes they've seen.
The mistakes they've seen others make.
Exactly. Those insights are invaluable.
Because trainees can learn from those experiences.
That's right.
And beyond experience, what else makes a great trainer?
A good trainer is a good communicator.
Right. Being able to explain things clearly.
Yeah. Breaking down complex concepts. Explaining the why behind the regulations.
Keeping the trainees engaged.
You got to keep them interested.
So it's not just about lecturing.
No, it's not.
It's about creating a dynamic
learning environment.
Learning environment where trainees can ask questions.
That's right.
Share their thoughts.
Yes.
Actively participate.
Absolutely.
In the process.
The best trainers make safety interesting.
They do.
They make it fun.
They make it fun.
They get people excited about safety.
And if the training is engaging, the information is more likely to stick.
Absolutely.
Now let's switch perspectives.
Okay.
And talk about the trainees themselves.
These trainees.
What qualities should we be looking for?
Oh, a good derrick operator.
In individuals who are aspiring to become...
is mechanically inclined.
Safe and competent derrick operators.
They gotta love machines.
Okay.
They gotta be curious about how things work.
So it's not just about brute strength.
No, it's not.
It's about having a sharp mind.
A sharp mind.
And a thirst for knowledge.
That's right. Derrick operation requires both.
Okay.
You need the physical skills.
Yeah.
But you also need to be able to think critically.
Right.
Analyze situations, make good decisions under pressure.
It's like playing chess.
It is.
With a giant machine.
You gotta think ahead.
You gotta think ahead.
Anticipate what's gonna happen.
Anticipate the consequences of your actions.
That's right. And communication is key too.
Right. We talked about that earlier.
They gotta be able to communicate with the rest of the team.
The riggers. The signal person.
And everyone.
The ground crew.
Everyone on the job site.
So it's not a solo act.
No, it's a team effort.
It's a team effort.
Communication is crucial.
And perhaps most importantly, a good derrick operator has a deep respect for safety.
That's the most important thing.
They understand the risks.
They do.
And they're committed to following procedures.
Following the rule.
Wearing the right gear.
Wearing the gear.
And always putting safety first.
Safety above all else.
So it's not just knowing the rules.
No, it's not.
It's about truly embracing safety.
It's a way of life.
As a core value.
You got it. They're always on the lookout for hazards.
Okay, so let's talk about some of those specific skills.
Okay.
That are essential for derrick operation.
Let's do it.
Where do we even begin?
Well, one of the most fundamental skills is rigging.
Rigging, okay.
That's how you attach the load to the derrick.
Right, so you're using slings, chains.
All that stuff.
Other rigging equipment.
You got to make sure it's secure.
So it's like tying the perfect knot.
It is.
Making sure that load is balanced and secure.
Exactly.
Yep.
You don't want that load coming loose.
Definitely not. What other skills are crucial for derrick operators?
Well, they also need to be able to control the boom and hoist.
Okay, so that's the movement.
That's the movement
of the derrick itself.
You got to understand the controls.
Yeah.
How to use them smoothly and precisely.
So it's like being a conductor.
It is.
Orchestrating the movements of this massive machine.
It's a delicate dance.
With finesse and precision.
And the operator is the lead dancer.
Exactly. It's not just about moving the load.
No, it's not.
From point A to point B.
It's about doing it safely.
Doing it safely and with control.
And communication is a big part of that.
Right. We talked about the importance of communication.
We did.
But how do you actually train operators?
That's a good question.
To communicate effectively on a job site?
Well, you got to teach them how to communicate with everyone involved.
The riggers.
The riggers.
The signal persons.
The signal persons.
The ground crew.
The ground crew.
Everybody making sure everyone knows what they're doing.
And it's all about coordination.
So it's like a well-choreographed ballet.
It is.
With the operator as the choreographer.
Guiding everyone
through their parts.
And effective communication isn't just about speaking clearly. It's also about listening.
Active listening.
Active listening.
Paying attention to feedback from others.
Making sure everyone's on the same page.
So it's about creating a shared understanding of the task at hand.
Everyone working together.
Make sure everyone is working together.
Towards a safe outcome.
And
sometimes verbal communication isn't enough.
Right. What happens then?
Then you got to use hand signals.
Okay.
Radios. Other signaling devices.
So you got to have a backup plan.
You do.
In case things get too noisy.
Exactly. Job sites can be noisy.
Or chaos.
So clear communication is essential.
No matter what form it takes.
No matter what.
Okay, now let's shift gears again.
Okay.
And talk about hazard recognition.
Hazard recognition.
How do we train operators?
That's a big one.
To be vigilant.
You got to be able to spot those hazards.
And proactive in spotting potential danger.
Or they become a problem.
On a job site.
So you got to train their eyes.
Yeah.
To see the things that others might miss.
So what kind of hazards are we talking about?
We're talking about everything.
Okay.
Overhead power lines.
Okay.
Unstable ground. Improper rigging.
Okay.
Mechanical issues with the derrick.
So it's really about being aware.
Being aware of your surroundings.
And being able to
anticipate.
Anticipate those problems.
Exactly. And once you spot a hazard,
yeah,
you got to know what to do.
Right. So it's not just about seeing the danger.
No, it's
about knowing how to respond.
How to respond safely.
Appropriately.
That's right.
Stopping the operation.
Maybe stopping the operation.
Notifying a supervisor.
Making
immediate action.
Whatever it takes.
To mitigate the hazard.
We got to keep everyone safe.
So it's about making those split-second decisions.
Sometimes you got to make quick decisions.
That can prevent an accident.
That's right.
Okay. Now let's talk about something that no one wants to think about.
But we have to.
But we need to be prepared for
emergency
procedures.
Yeah, what happens when things go wrong?
How do we prepare operators?
That's where training comes in.
To handle unexpected situations.
You got to practice those emergency procedures.
Calmly and effectively.
So they know what to do.
So they have a plan.
If the power goes out.
Okay.
If there's a mechanical failure. If the rigging fails.
If anything unexpected happens. They need to know what to do.
Exactly. They need a plan.
And those protocols
need to be clear. That's well rehearsed.
And well rehearsed.
Yeah. So they can respond quickly.
So that when they're under pressure,
yes,
they don't have to think.
They just react.
It
becomes second nature.
So training should include
simulations,
drills,
practice those procedures,
giving them a chance to practice those protocols in a safe environment.
A safe and controlled environment.
And communication is crucial.
Communication is always key.
In those emergency situations as well.
Yes.
Operators need to be able to communicate clearly.
With everyone involved.
With other workers.
Emergency responders.
Supervisors. Making sure everyone is working together. To resolve the situation safely. And efficiently.
Exactly. Communication can save lives.
It can.
It's an emergency.
Absolutely.
Okay,
so we've talked about a lot of important elements of training.
We have.
But I want to touch on one more thing.
Okay.
Documentation.
It might seem like a minor detail.
But it plays a crucial role.
It does.
In ensuring the effectiveness.
Accountability.
Of any training program.
Transparency.
So how does documentation?
It helps track the progress of trainees.
Okay.
Make sure they've met the standards.
Tie into operator training.
Provide evidence of their qualifications.
So it's a record.
It's a record
of their training.
Of everything they've learned. Types of Derricks topics cover hours of training.
Wow. So it's very detailed.
Results of assessments, certifications, licenses.
So there's like a safety resume.
It is. It shows what they know.
Okay.
And it's not just for the operator.
Right.
It's for employers, regulators, insurance companies.
So it shows that they've received the necessary training.
Exactly.
But they're qualified.
Builds trust.
To operate Derricks safely.
Confidence.
So documentation is really about accountability.
It is.
And transparency.
Transparency.
Showing that everyone is taking safety seriously.
Absolutely.
Okay. I think we've covered a pretty comprehensive overview.
I think we have.
Of Derrick operator training.
From the basics to the advanced stuff.
Wouldn't you say?
We've hit all the key points.
We've explored the key elements of a successful training program.
Tailored training, OSHA standards, hands-on experience.
And we've emphasized the importance of communication, teamwork, and documentation.
Documentation.
It's all connected.
It is. It's all about safety.
Absolutely. And well-trained operators
are the key.
Are the foundation.
To a safe work environment.
Of a safe and productive work environment.
Absolutely.
Now, we've talked a lot about traditional training methods and safety procedures.
The old ways.
But there's a whole other world out there.
There is.
That's changing the game when it comes to Derrick safety.
Technology.
Technology.
That's right. Technology is revolutionizing everything.
Okay, now we're talking.
We are.
I'm ready to step into the future of Derrick safety.
Let's do it.
Let's explore how technology is shaping this field.
It's making things safer than ever.
And making these operations safer than ever before.
Data sensors automation.
Okay, I'm intrigued.
It's an exciting time.
Let's dive into this world of technological advancements.
Let's dive in. It's an exciting time to be involved in Derrick safety.
It is.
Because technology is rapidly changing things.
So it's like giving those old school Derricks a digital makeover.
A digital makeover.
Gripping them with the brains and the brawn.
That's a great way to put it.
Handle even more challenging tasks.
And it's not just about fancy gadgets.
Right.
This is about...
It's about solving real problems.
Solving real problems.
Okay, I'm hooked.
Good.
What are some of the technologies that are making the biggest impact?
Well, one of the most transformative technologies...
on Derrick safety.
...is sensors and data analytics.
Oh.
We can now outfit Derricks with all sorts of sensors.
So these sensors are monitoring everything imaginable.
Load weight, boom, angle, wind speed, ground stability.
Oh, so it's like giving the Derrick
a
sixth sense.
It's like it can see and feel everything.
Allowing it to perceive its surroundings and respond.
Exactly.
Right.
And the data from these sensors is analyzed in real time.
So this data is being used to identify potential hazards.
To identify hazards.
Alert operators to issues.
Alert operators.
And even automatically adjust.
Exactly adjust.
The Derrick's operation.
To maintain safety.
So it's like having a virtual safety supervisor.
It is like that.
Constantly monitoring.
Always watching.
And providing guidance to the operator.
That's a great analogy.
Okay.
And all this data can be used to track performance.
Oh, that's interesting.
Spot trends, predict maintenance.
So we're not just reacting to problems.
Yep.
We're proactively preventing them.
That's the goal.
Using data to anticipate issues before they even arise.
That's what we want.
That's a game changer.
It is.
This data-driven approach
is
also changing the way Derricks are inspected and maintained.
It is changing everything.
So traditionally, Derrick inspections were primarily visual.
Someone had to go out there and look at it.
Right. The inspector would look for signs of wear and tear.
Exactly.
But
now we have sensors.
We have all this data about the Derrick's health.
We can see things we couldn't see before.
It's like giving those inspectors superpowers.
Letting them see beneath the surface.
That's right.
Detect hidden problems.
We can see things like vibration, temperature, pressure changes.
Wow.
That might indicate a problem.
So we
can fix it before it becomes a big issue.
We're shifting from a reactive approach to a proactive one.
Exactly.
Addressing issues before they turn into major breakdowns.
Preventative maintenance is key.
Or safety hazard.
Absolutely.
And this data can be used to optimize maintenance schedules as well.
It can.
Making sure components are serviced or replaced.
At the optimal time.
At the right time.
Yep.
To minimize downtime and keep the Derrick running smoothly.
Exactly.
It's like having a crystal ball for maintenance.
Predicting the future and keeping those Derricks.
That's what we want.
In tip-top shape.
We want those Derricks running smoothly.
Speaking of predicting the future.
Okay.
Artificial intelligence, or AI.
Ah, yes.
Is another exciting technology that's making an impact.
How is AI being used?
How is AI being used?
It's being used
to enhance Derrick's safety.
To develop systems that can learn from past data.
Okay.
Recognize patterns and predict potential problems.
So it's like Having a safety oracle on board.
Always analyzing.
Constantly analyzing the situation.
Looking for potential risk.
And providing insights.
Based on all that data.
Based on a vast pool of knowledge.
And experience. Yes.
Okay, so AI systems can analyze data.
They can?
From sensors, weather reports, operational logs.
Even video feeds.
Wow, even video feeds.
You can see what's going on.
To identify potential risks.
And then they alert the operator.
So it's like having a second set of eyes.
Or a second brain.
Always on the lookout for danger.
Exact.
And AI can also be used to develop more realistic training simulations.
So operators can practice.
For operators.
Responding to different situations.
So they could practice in a safe environment.
Responding to challenging situations.
Exactly.
Safe environment.
So they're better prepared for the real world.
Wow. So AI is enhancing safety.
It is.
On the job site.
And improving training.
And improving the effectiveness of training programs.
It's a powerful tool.
That's incredible.
It is.
Now, let's not forget about communication. We talked about that a little earlier.
Communication is key.
But how is technology making communication clearer and more reliable on those noisy and chaotic job sites?
You had hand signals and voice commands.
Right. Which are not always reliable.
Not always.
Especially when it's really loud. It's hard to hear.
It's like trying to have a conversation.
It is.
At a rock concert. Exactly. You can barely hear yourself think.
You can't. But now.
Now we have wireless communication. That's radios.
So everyone has their own personal communication channel.
Clear and reliable communication.
Ensuring those messages.
Even in noisy environments.
Get through loud and clear.
Exactly.
Okay. And these systems can be integrated with other technologies as well.
Sensors, AI.
So it's not just communication between workers.
Nope.
It's also the derrick itself.
That's right.
Communicating with the operator.
Providing vital information.
Creating a much safer and more responsive operating environment.
Exactly.
Wow, this is amazing.
It is.
Okay, so we've talked about sensors, data analytics, AI, improved communication.
All those things.
What else is brewing in the world of derrick safety technology?
Well, another exciting area is automated derrick systems.
Okay, now that sounds futuristic.
It is.
Tell me more.
These systems use sensors, actuators, and software.
About these automated derrick systems? To control the derrick's movements.
So it's like putting the derrick on autopilot.
It is like that.
Allowing it to perform tasks without direct human input.
Well, not completely.
Okay.
Not quite there yet.
So not fully autonomous.
Not yet.
But semi-autonomous?
Semi-autonomous.
Okay.
We're seeing those features being used now.
Could you give me an example of that?
Sure. Some derricks have systems that can automatically level the boom, prevent overloading, or stop the load safely if something goes wrong.
So it's like a built-in safety net.
It is.
That takes over if the operator makes a mistake.
Or if there's an unexpected problem.
That's incredible.
It is.
And that these systems are going to continue to evolve.
They are.
And become even more sophisticated.
More features, more safety, more efficiency.
This all sounds incredibly promising.
It is.
But I have to ask, what are the challenges?
Yes.
What are the limitations of these technological advancements?
Good question.
Are there downsides?
There are always challenges.
Okay, what are some of the things?
Well, cost is a big one.
We need to consider.
The systems can be expensive.
That makes sense.
Especially for smaller companies.
Right.
Or companies with older equipment.
So cost is one thing.
You also need expertise.
Okay.
To install and maintain these systems.
Right. You need people who know how to use this technology.
You do.
Okay, what else?
Cybersecurity.
Yes, cybersecurity.
That's a big concern these days.
Because these systems...
They're all connected.
Are all connected to the internet.
And that means they're vulnerable to hackers.
Okay, so cost, expertise, cybersecurity.
Those are all important considerations.
Those are all important factors to keep in mind.
But the biggest limitation is that technology is a tool.
It's not a replacement for human expertise.
You still need skilled operators.
Because there are always going to be unexpected situations.
Things that the technology can't predict.
That the technology can't handle.
That's right.
So it's really about...
It's about combining
the best of both worlds.
Human expertise and technology.
Giving those operators tools they need
to make the best decisions.
To do their jobs safely and efficiently.
Exactly.
Well said.
Thank you.
I think we've covered the exciting world of technology in derrick safety.
It's an exciting time.
Remarkably well.
Lots of potential.
Highlighting both the transformative potential
and challenges.
And the challenges that come with it.
But we're moving in the right direction.
Absolutely. Now, Now, as we wrap up this deep dive into the world of Derricks safety.
It's been a journey.
From OSHA regulations and A-frame specifics.
All those details.
To operator training.
So important.
And the impact of technology.
But the future is bright.
I want to leave our listeners with one final thought.
I'm listening.
We've talked about a lot today.
We have.
Regulations, training technology, safety culture.
All important stuff.
But at the end of the day,
it all comes down to people.
It all comes down to people.
The operators, the riggers, the signal persons.
Exactly.
Everyone involved.
It's the people who make the difference.
They do.
Between a safe and successful operation.
Or an accident.
Or a disaster.
Their decisions matter.
So as we conclude this deep dive,
yes,
I want to encourage everyone involved in Derricks operations
to take safety seriously.
To take ownership of safety.
Be vigilant.
Be vigilant.
Communicate.
Effectively.
Put safety first.
And always put safety first.
That's the most important thing.
Absolutely. And with that, I want to thank our listeners.
Thank you for listening.
For joining us on this journey.
I appreciate it.
Into the world of Derricks safety.
It's been fun.
And a huge thank you to Safety One Source.
Yes, thank you.
For sponsoring this deep dive.
They're the best.
And for their unwavering commitment to promoting safety in the workplace.
Safety is their passion.
Be sure to visit their website.
Lots of great resources there.
And social media channels.
And expert insights.
For a wealth of resources and expert insights.
They know their stuff.
And to our listeners,
yes,
thank you for tuning in.
Stay safe out there.
Stay safe out there.